Greetings. This is an HP 8753D. It says 6 GHz on the front panel, but this is actually a 3 GHz unit. Let's see how it works. First, the power on. All of the lights illuminate as they should. Comes up bright and clean. This has 06.14 software, which is the latest version for this particular hardware. 1987 is the date there. Nice flat, clean response. If we go to channel 2, that's the ST2 response, also nice, clean and flat across the band. Let's go ahead and take a look at the port response when we have a load on the lines. So, alright, so across minus 50 dB there. Over here, the worst part of the band, you're looking at minus 38, which is great for an uncalibrated response. The only place where it's looking a bit off is right here at the very bottom, minus 23. That will go away when we calibrate it. Go ahead and look at the response from the other port. Here is port 1. And port 1. And here we see a very, very similar response to the other channel. Let's go ahead and put this up a little bit higher so you can see everything here. So again, at the low end, it's a little bit, as we move it across, it quickly jumps to minus 46, which is excellent. All the way across here at 2 GHz is minus 46, and then up at the high end at 3 GHz, it's minus 38. So solid return loss in the uncalibrated state. Let's go ahead and take a look at a filter and run a calibration and see the rest of the performance. And then we have a mini circuits NBP 177-1. It's a bandpass filter, just to show the ability of this instrument to measure. When we do that, we're starting to see the filter response. We see it down here where it should be. This is the S11, or the S11. So not super deep. If we go ahead and switch to an S21 response, this is what we would expect. This is the uncalibrated state. What we really want to do is see what sort of response we can get while it's calibrated and see how good we can get. So in the uncalibrated state, we're still getting approximately minus 1.8 dB, which is within a dB of what we should be getting. And then here, we're seeing the out of band at about minus 80 on that side, and over here, we're seeing, again, about minus 80. Now when we calibrate this, you'll see an improvement in what the filter looks like, but let's first figure out where we want to start and stop. Let's keep the start the same. Let's stop at 0.8 GHz for now and see what that looks like. That's seems like a reasonable range for this filter. Let's go up to 801 points. So it'll slow down the measurement a little bit, but make things a little bit more accurate here. Let's go ahead and run a calibration. So in order to run a calibration, you need a cal kit. We are going to use a very basic cal kit, or pieces of a cal kit. This is the 85031 6001. It has an open and short, and this is a 50 ohm load, which is the HP 85031 6002. And then we're going to go to the calibration menu. We're going to do a full 2-port calibration. And so we will disconnect our load for now. I'm going to do a reflection first. So the forward port. And we're going to go for open. So we connect our cal reference. If we want to be really accurate, we should torque these. And we should be holding that with another wrench, which we don't have. So forward open. And now for the reverse. We're going to go first. Short. And less glue. Extend it over there. For transmission, we're going to use, again, a standard HP cable. Alright, so we're going to go and do the transmission, both forward and reverse, which is supported by the latest version of software, not the earlier software, so it's very handy to do that all at once. Isolation, we are going to admit isolation, and we're going to say done. The blinking that you see on screen, it should not blink. The reason it blinks is because the software was updated, but the power supply was not modified. This is the capacitor that you need to modify the power supply. It requires some disassembly. That has not been done yet. If that blinking bothers you, you can put in this capacitor and that blinking will go away. Alright, so with the calibration done, we're going to go ahead and remove the calibration cable, filter back in place. Alright, so what do we see? We see that this is a little bit flatter. We're going to go ahead and see what we can do to clean this up further. What we're going to do first is scale reference, and we're going to do the reference position. We're going to move that up to 9 so we can see what's going up down here. The next thing we're going to do is we're going to go to averaging menu IF bandwidth, and we'll take that from 3000, we'll bump that down to 100 hertz. When we do that, it will slow down the measurement considerably, but will also improve the accuracy. So it goes through once and you won't see an update, and then the next time it comes across, again, very slow, but see how clean that got? So it cleans it up considerably. Now, if there are some extra reflections here, those reflections are a function of this cable. If we want to get rid of that, it turns out the S12 and the S21 are slightly different for this configuration when you have the cable attached to the filter. So if we go to measure, and we go for S12 instead of S21, it will now measure the filter the opposite direction. We're going to go back to averaging. We'll change the IF bandwidth to 100 hertz one more time. And this time you'll see a beautiful curve here on the bottom once it goes through once. Again, quite slow because of the number of points and because of the processing of this machine, but if you look at this value here with number 1, you can see incredibly low noise, and that's because this is an awesome instrument. Now, if you say that, gee, this is too much noise for me still, and you want to get rid of that, you can go to the stimulus menu, and you can change the power, the output power of this device. Let's go ahead and just do a data to memory and a data and memory, so we have something to compare to. And then we're going to go ahead and take the stimulus, we're going to take the power, and we're going to bump it from 0 up to 9 dBm. Let's see what happens when we do this. It's going to, again, take a minute to sweep, but because we increase the power, it will actually improve the noise figure here, and all those squiggles will become incredibly flat on the data line. It's hard to see with both the data and the memory displays, so we're going to go and do a data only so you can see how flat it is. And beautiful curve, very low noise, and now we're going to go ahead and put some markers on here just so that we can see what we get. So at the low end here, it's off the screen, but we're at like -106, which is awesome. Let's go ahead and put the second marker up here in the bandpass region. And it's minus 1.67-ish, and then we'll put a third marker over here and see what it is, whatever, 440 megahertz, and it's around minus 80. Beautiful instrument, working great, but it has some issues, so let's talk about the issues. Number one, keypad cover here. You'll note this is nice and shiny, not plastic like the original. This is made out of aluminum. It is hand drilled and filed to match the front profile. The original ones can be obtained out of Korea. They're about 30 bucks plus shipping. There may be other sources, but I just didn't feel like it was worth the wait. In addition, if you want, you can get ones which are computer printed on eBay for about 20 bucks, 15 bucks plus shipping. So if you want a plastic printed to match the machine better, do that. It has some adhesive tape right here holding it in place. You just pop that off, pop on the new one, you're good to go. Number two, this right here. Obviously this is not original. The original switch is maintained back behind, but this is a new button. The reason I created that new button is because the old one was sheared off the machine. So that is hand machined by myself, perfectly functional, but it is actually stiffer than the original button, and that had to do with rebuilding it. Normally these would spin very easily. It is a little bit hard to spin, and it's a little bit lopsided there when I'm pushing it. So not 100% perfect. If you want perfect, we can take a piece off another machine, but the buttons are about 50 bucks, so you take your choice. What else? Oh, one other thing to mention here, which is an issue potentially with the machine. In the source module, which is located back here, there is a step attenuator. The original one for this unit is a 3321Q. This unit right now has something like this, which is a 5086 87-15. The problem with that is this. When you go to menu and the power, +9, no problem, right? 0, again, no problem. You'll get a little bit more noise, but whatever, who cares? When you're -80, you have a little bit more noise at 0 dBm. That's normal, that's the way the machine's designed. If you go to -9 dBm, still again, no issue. However, if you go to -10, we'll just step it down here. What you'll see is when we get to -10, we'll wait for this with the screen to clear, but we've now gone to -10.05, and why is it not causing an issue? So in this mode, it is acting exactly like it should. Let's go to something else and measure S11. And it's behaving normally. S22, it's behaving normally. Okay, my bad. I thought on this machine when you went to below -10 that it had an issue with the step attenuator. I'm not seeing it now. That issue may or may not exist. Alright, I gave up. I thought it had an issue between below -10. You rarely use lower than 0 dBm output power, but I can't get it to repeat that issue. There's one other issue, which is right here. There are, and I will include a picture of this, there are the 3 samplers for the unit. One of the samplers has a broken connection on the end, so in order to get the cable to stay in place, it required the use of some zip ties. Obviously, if you had to work on the unit, that would be a disadvantage. The sampler itself works fine. As you've seen from the results here, the filter measurement, beautiful. It curves and everything, so no issues there. But there is a physical problem on that port coupler. So some minor cosmetic issues here and here. And then the issue with the sampler and possibly this, but I'm not able to reproduce that issue at this point. And then of course the capacitor issue on the power supply if you want it to not blink during the calibration. That's it. Thank you for your time.